People haven't set foot on the moon in several decades, but the situation is going to change soon. NASA's Artemis program is going to send a few missions to Earth's natural satellite. The first astronauts might step on the surface of the moon already in 2025, as part of Artemis 3, if the current schedule holds, that is. And then the next stage will start, and it will be an even more ambitious project than sending humans to the moon again. NASA wants to construct a base camp at our satellite's south pole. Such an outpost will help the Artemis mission to break the previous record for the longest stay on the moon. So far, it's 74 hours, 59 minutes, and 38 seconds. Plus, such a camp can serve as a jumping-off point for missions setting off for deep space. According to NASA, at first it's going to be a small camp, accommodating missions for a week or two. But soon, it'll grow in size and complexity and will be able to sustain crews for a couple of months at a time. There might also be an open-top rover similar to the one used in the Apollo missions and an RV. These options can provide mobility for astronauts while they live and work at the camp. With each new trip, the level of comfort of space explorers will increase. Specialists are now developing the technologies that will help people to work more easily on the moon, far away from home. There's also hope that building such a camp can help us prepare for an even more challenging step: human exploration of Mars. For the camp to function properly, it's very important to be able to find and extract resources from the satellite's rocks and dust. These resources can include water ice, metals, oxygen, and even some building materials. It'll help to lighten the load with supplies delivered to the moon. It can also potentially allow astronauts to remain there for longer periods of time. Now, why the lunar South Pole? There are two very important reasons. First, building the base camp there will allow astronauts to have periods of continuous light from the sun. The moon is tilted in such a way that its south pole experiences up to 2 months of continuous light every year, when the sun is circling above the horizon all the time. And all this abundant sunlight can provide the camp with a lot of solar power. At the moment, NASA is trying to design a solar array that could stay more than 30 feet in the air. This way, it'll be able to make the most of the available sunlight. The second reason for choosing this location is deep craters that have been shrouded in darkness for billions of years, also because of the moon's peculiar tilt. Some of these craters haven't seen sunlight since the time of their formation. They're also known as permanently shadowed regions, and that's where scientists have found evidence of water ice. If we manage to access this frozen water and it turns out there's a lot of it there, it'll be hugely valuable for the inhabitants of the base camp. Plus, it might supply flights back to Earth, or further on to Mars. We don't know yet whether there's a lot of water in that region or whether it's free of contaminants, but NASA is going to find out. One of the ways to do it is to use Viper. This mobile robot is likely to arrive at the lunar South Pole in 2024. The Lunar Terrain Vehicle, or LTV for short, is scheduled to arrive on a mission in 2025. Astronauts will be able to operate it remotely, and it's likely to be able to avoid such hazards as rocks and craters on its own. Astronauts will then explore their surroundings either from the safety of the lander on earlier missions or later on from the base camp itself. Plus, NASA will use the LTV to conduct scientific or mission-related work even during periods of time when there will be no humans on the moon. The vehicle will play a crucial role in searching for water ice and other resources. But even though the LTV's remote-controlled capabilities are quite innovative, its design isn't going to change much. It'll look almost like the rovers that have come before it. If astronauts decide to drive the vehicle with its top open, they will have to put on their spacesuits, and that's not very comfortable. Donning such a suit can easily take hours. Plus, the duration of missions always depends on how much oxygen each astronaut's spacesuit has left. That's where NASA's RV-like concept, known as the Habitable Mobility Platform, comes into play. If this project succeeds, the RV will have a pressurized interior and life support systems, meaning passengers will be able to have a ride without their spacesuits on. This will definitely make life easier for astronauts. The final design of the vehicle isn't ready yet, but the main goal is to allow several people to live and work inside the vehicle for up to 2 weeks. Now let's have a look at what the future lunar cabin might look like. Its design hasn't been finalized either, but NASA is looking at modular and inflatable structures. It may help to create larger spaces for crews to live in. Plus, such kinds of structures are more compact and lightweight, so it will be easier to transport them to the moon. But there's one more intriguing possibility. How about a large-scale 3D printer that will use lunar soil and rock as its raw material? Such a machine might be able to produce bricks and other shapes, assembling dwellings from scratch. A prototype 3D printer is now building a test structure in Houston. Also, the first towns on the moon could probably be built in craters. They might be covered with protective materials like plastic, reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it can make it easier for astronauts to walk and even run on the moon's surface, it's not so great in the long run. That's why inside the lunar base, there might be an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1 to 5% of mineral density per month. A geologist from the University of Notre Dame, who's been studying samples of lunar soil, says that rocks or dust may have a key role in protecting astronauts from radiation coming from solar flares and cosmic rays. On Earth, the planet's atmosphere and its magnetic field filter out most of this harmful radiation. But the moon doesn't have the same shield because there's no atmosphere like on our planet there. The very weak one that our natural satellite has is made up of some unusual gases that haven't been found in the atmosphere of Earth, Mars, or Venus. That's why people working there will need extra protection. The experts say that up to 6 feet of lunar material might be needed to shield astronauts from the radiation. But besides building materials and water, there's another crucial resource on the moon, and it's oxygen. NASA hopes to start extracting this gas from moon rocks. They also hope to find metals like aluminum. This could allow astronauts to live off the land, and the base would become much more self-sufficient than expected. It could turn into a resupply station for spaceships heading for Mars. But a colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. Lunar camps are much easier to build and maintain. There will likely be direct spaceship routes connecting the satellite with Earth, and people will need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon will be growing, developing, and changing non-stop.